Welcome everyone, whoever is in the stream right now. I'll be talking about my book, Street Coder, and specifically a part of it, like a small portion of the book where I mention useful anti-patterns. And uh, what are anti-patterns? You might wonder. And basically, anti-patterns are the counterparts of best design patterns and best practices, basically principles and stuff. In programming world, we have certain um, paradigms in software development. Like over the time of programming, we developed some best practices that we can apply to programming without needing to resort to, how we can work on a certain problem. So they are like shortcuts for us. But the bad thing about them is they actually became like uh, let me face you here. So they became like very established, but at the same time they became like a cargo cult of programming. Like you could actually solve a problem with a different approach than a prescribed pattern. And in useful anti-patterns, I actually go over some techniques that go against some of the some of those paradigms, principles, and design patterns. What do we have here? So let me start first by talking about a little bit about myself. And I'm a self-taught programmer. I haven't studied in college about software development. I literally taught myself because I grew up in a small city in central Turkey, so without access to many books or resources for programming. So that actually made me to reach out for um, really intricate details of programming through like scrapping pieces of magazines and asking friends, anyone who knows about it. So I had to pretty much learn everything myself, and that actually gave me some perspective about software development, which some people who went through college to learn about it may not have. And one of the greatest things I've learned was that basically some of the concepts we might find boring or useless in a university curriculum might actually be much more useful in a professional setting than we think about. And similarly, many of the best practices we learn or bad practices we were told to stay away from are actually can actually be useful in those settings. So I think I gained some perspective that I can provide to developers who are at the beginning of their careers, that they can apply to their own personal development and personal growth, basically. I later in my career worked as a software engineer at Microsoft. I also founded a popular website called Ekşi Sözlük, which is one of the most popular Turkish websites in the world at the moment. And I have now over 20 years of professional experience on software development. Street Coder is a book that I try to convey some of my experience in order to cause a perspective change in developers. That's what I'm aiming at, basically. And in the book, I try to give some tips and tricks, like here, what I'm gonna do. But what I'm trying to do, instead of trying to be a comprehensive programming guideline book, I try to be uh, a guiding light for developers who want to, change their attitudes towards, as I said, established paradigms and best practices. And what I mention is usually things that are most overlooked in software development. So, as I said, I prepared long exercises, and probably we won't have time to go over each and every one of them. But the good thing is, all this stuff is in the book. So if you buy the book, you will have access to everything there. But I'll try to be as clear as possible in this presentation. So as I said, antipatterns are just counterparts of design patterns or best practices, principles. I use it as a general term, basically, that things that are looked down upon in software development currently. And what are those like? So one of the things that you might have trouble with doing yourself is like repeating yourself. I mean, one of the best principles is dry. Don't repeat yourself, right? So I instead suggest repeating yourself in the book. So I recommend doing the opposite of not repeating yourself. So why was there a principle called dry, don't repeat yourself in the first place? And one of the reasons for that is people didn't want to do everything from scratch again. They don't want to repeat themselves. They don't want to waste time typing something over and over, and or they don't want to be burdened by the maintenance of maintaining two things at once. Let's say you have a piece of code and you want to use it in two different places. In that case, repeating yourself would burden you with updating two different places when you have an update for a change for that piece of code. So you have to work twice as much, right? That's why everyone says don't repeat yourself, just reuse the code. But the thing is, it can be bad, or it's not always bad. Make no mistake about it. It can be useful most of the time, but it can be bad when you actually create complexity and coupling with it. And I'd like to go over an example and show you how this can happen and turn into from a snowball to an avalanche by just trying to reuse the code all the time. So I'd like to go over an exercise here. Let me bring up Visual Studio. There you go. So let me create a project. And if you happen to have any questions, please feel free to ask. Hi, Umur. Hi there. Thanks for the greetings. Yes. So I'm gonna just create a console application because it's the easiest to reproduce it like this. And in case I have trouble with the code a lot, I can bring back one of the older solutions, but I just want to write it from scratch so you experience the process with me here. So let's call this new stream. .NET 5 is fine. So let's create our project here. Okay, we have a simple hello world application here, right? And let's say, let's have a simple problem like form normalization. What's normalization? Normally, when you have a form on your web page or on your web application, uh, you tend to, I mean, businesses might decide to, normalize the fields. Like if you have a lowercase name, they want to, as in this case, let's say I type my name here, and people might want to normalize it to this, just to see it like in a uniform way, so all customer names look uniform. That's not usually a good idea. I mean, because there might be cultures where the lowercase might be preferable, or there might be a personal preference for lowercase for their name. So I don't actually recommend doing normalization, but you might encounter such a case in your career. Basically, your boss might come and say, hey, just normalize these, and I don't care about anything else. So how do we do this? This looks like a simple problem. So I'm just gonna ask for an input. Read line. Let's read name from the console and ask for the name. Enter your name. Right. So we have the name here, and we'd like to print the output here. Like this. So when I type in my name as is, it'll write it as is. So I'd like to capitalize this, right? So what I'm gonna do is just call a function, and I'm gonna generate the code for it. I'm using Visual Studio's code generation tools a lot because they help me. Because let's repeat this again. So yeah, there's a question in the stream, but I'm gonna answer this later if we have time remaining. Maybe I can leave 10 minutes before stream ends for answering these questions. Okay, so I have a function here, right? What I'm doing is I just press Control period, and I get presented with a menu, refactoring menu, and I already have the option of creating the function. So that's what I'm doing. I just press enter and see it here. So what we do is just split the name into its words and capitalize them individually, right? So what I'm gonna do is I'm gonna split this into an array like this, using spaces as the separator. And I'm gonna just go over each word. Oops, not like this. Because I'll need index for placing the normalized word in the array again. And I'm just gonna return string join the new words like this, and I'm gonna replace it with capitalized word because I'm gonna capitalize a single word here, and I'd like to use this in a separate function because I think this helps the readability of the code, which I mentioned in the book a lot about this. I mean, you can make the code easier to read just by using proper names, proper structure in the code without using any comments. So far our code looks pretty much readable without any comments basically. And so what I'm doing is I'm creating another function using the same method before, and I'd like to rename this to word. And how I'm gonna capitalize a word, I just take the first letter and lowercase the rest of the letter while uppercasing the first one, right? So how does this work? If word is single letter, I'm just gonna return the first letter uppercase. If it's empty, it's gonna, two upper would do nothing. So that's pretty much it, right? So and then I'm trying to, now I'm gonna just take the first letter uppercase and return that. So first letter is word 0. It's a character, so I can't use .to upper because it's not a string, it's just a character, and we have a separate method for that. And I'm gonna concat the string with it, and I'll come back to that later, with the rest of the word, which just takes the string right after the rest of the word. And that's pretty much it. So we have our code here. Oops, I forgot the two upper to lower here. So yeah, we are using string concat here, and in the book I mentioned that string concatenation, joining strings together, might actually be a bad practice, but there are cases where you can use it actually. Since we don't care about the performance characteristics of our code here, because we'll be talking about repeating ourselves, right? So so that's why I'm using this method, but there are faster ways of doing this. There are techniques explained in the book how you can make this faster, but I'm gonna try to keep this simple, basically. And yeah, this is what we have, right? Let's try to run it. Let me show the full desktop, because I'm gonna launch the app just to make sure that if it works. So yeah, it seems to be working fine. And now let's say our form has other fields, like for example, shipping notes to the delivery person, right? And we'd like to normalize that too. Let's just assume, for the sake of the example, that we'll be using only only single sentence in the shipping notes. It can be a paragraph in actual real life scenario, but in this scenario, it's important that we want to do a different normalization, different kind of normalization. So with name, we just want to turn this to this, right? But here we'd like to shipping notes. Let's again say this is capitalized, and leave it at the door like this. Leave it at the door. We don't want to distract the delivery person, so we just say leave it at the door in a polite way. We don't want it to be shouting. So here we have a different kind of normalization requirement. But the thing is, when we're developing code, we are so keen on reusing code. You know, this kind of capitalization, we have something close enough to this. So many developers would just go ahead and change capitalized methods slightly just to introduce the logic. So in this case, let's just write the shipping notes normalized. Like this. Let me group these like this so we see batches. So we have capitalized here, but the thing is, every word would be made uppercase individually. So what a typical developer would do, they might add boolean is description here, and just add a separate case here. Description false. If it's a description, I only want to capitalize the first word. So let's check if it's the first word. Or not this description. Otherwise, I just lowercase it. Not description. Not sure if it's the right logic. Let me see. Let's just. I'm not sure if it's the if this is right now. If it's is description, not is description. I don't want to. Yeah. Yeah, but it looks. Yeah, it looks okay. Yeah, it's fine. Let's see if it works. So let's put our is description true here. So we want the proper capitalization, right? Like this. So, oops. And I just passed name here. Shipping notes. Yeah. So, yeah, let's see. Yes, so we achieved what we wanted, basically, right? With very small change in the program. We added a single parameter and changed our logic a little bit. This is what applying dry in such a stubborn way everywhere gets you into. When I try to, let's say we have more, like we need a file name to normalize, and our file name is should be converted to in a specific format, like let's say if it's invoice report XLS, we want it to become invoice report.xls, right? We want it to be properly capitalized in our application for some reason, who knows? And you see, I again used capitalize function, and the more I rely on this code reuse, it actually binds me more to the same piece of code. And because of that, I try to fit in everything into the that piece of code without trying to repeating myself. That's why actually it'll become harder in a bit. You'll see it. So let's say I'm gonna write the output as well. So yes. And now what I'm gonna do is so it's not a description, it's a file name. So I'm now actually overloading this function with a lot of stuff, and it's file name boolean false. So now I've got a new case in the function. The thing is, the more parameters a function gets, it becomes more complex. Every parameter adds a new branch of state, and it can actually complicate the function in orders of magnitude depending on how your logic is. Now, first, my splitting character isn't space anymore, it's underscore, as you can see here. I'd like to use a different separator. So first I have to choose a separator here myself. Is file name space underscore and use this instead, right? To split and join back. So I added another logic here. And here, I can't use to upper and to lower themselves because file names can have different requirements for characters. The problem with characters and using to upper to lower are that to lower and to upper actually adheres to system's current locale, current region, in order to decide what's uppercase and what's lowercase. And even though it's primarily the same between all Latin languages, it can be different. For example, the uppercase for dotted I is dotless I in English. But in Turkish, the uppercase for it is actually dotted I. And similarly, the lowercase for dotless I in Turkish is dotless I again. So there are cases like this in other languages with other letters too, but this one, Turkish I, it's called, it's one of the most problematic ones. And because your application might be running in a Turkish locale or some other locale, because you might actually run it on in a different country, or your country might be using a different locale. And because of that, the business might not want to use these characters in the output. And in that case, we have alternatives in C# .NET called to upper invariant and to lower invariant, and we need to use those instead. So what do? We actually pass our file name to capitalize word2 because we want to use the correct one, and add a parameter here. You see how complicated it's getting. So yeah, I get a question about this. How can we decide when to split methods? Yes, so it's basically pretty much about the scope of the function when you want to split it. And what I'm gonna do is right now I'm gonna add this isFileName function, and after I'm finished with this task, I'll be more focusing on how we can split this into properly, because we'll be talking about repeating ourselves. And so isFileName equals false. This would be the path a developer would take, because just adding a parameter might look really simple, but the thing is we are actually complicating our work here. So right now, if it's a file name, I'd like to return a different to upper invariant to lower invariant. I like to use these instead. And here similarly, it's file name yeah. So I think we're done here, but the thing is, you see our code is getting a lot complicated, too complex. Even reading it is a problem, you know. There's a lot of logic going on. Is file names, is descriptions everywhere. Even this word takes is file name parameter. Like it's getting really complex. So let's try this out. And file name invoice report. Yes, it worked. Okay. But the thing is, would you like to, you know, maintain this? And more importantly, if you see here, we have two parameters, is description and is file name, but they are not mutually exclusive. I mean, you can have a case where both is description and is file name are true, and a developer in your team might be relying on that behavior because you presented this alternative to them. You present these options to them, and they might actually think that, hey, I'm gonna use these two options together to get what I want. And in that case, you get a, you know, Frankenstein of a function. it really becomes unmaintainable mess because of that. So how do we do this ideally? And what how we should do it is basically just repeating ourselves, a lot of copying and pasting basically, because the concerns of these three scenarios are actually entirely different, and we're just fooling ourselves by thinking that they use some common logic, but actually they don't. I mean, they differ in almost every case. And here you don't gain anything by trying to cram your additional logic into an existing function. You don't get a benefit from reusing the code here. So what we do is let's just extract these in their own methods. No, not necessarily. So what we should have is a capitalized name function and capitalized shipping note function, shipping notes, or capitalized file name function. And yeah, that we should have three different functions, and they should only get a single parameter, not two. They should be working like this. And let's create these. So now actually our functions have more meaningful names, and they might have common logic, a bit of it at least, but let's just copy paste it into other functions and modify them based on their logic. So our separator is here, space already. We don't need this. We don't need this. We can still keep capitalized word, but we don't need its file name, because we know that capitalized word is just for words, regular words, based on the language, basically. Let's go over this one and remove this case here, because we don't want this here. And let's have a different one for capitalized file name component, right? And use invariant. Now you see we have a bug in the original code actually, because we forgot to use different two upper functions here based on file name is file name parameter, because code is unreadable. When code is unreadable, you get more bugs basically. No question about it. Okay. And as you can see, we are copy pasting code and changing it in slight ways, subtle ways, but what we do is actually meaningful, because we are trying to be as clear as possible and don't cause us trouble by trying to create a spaghetti of a code, of a piece of code. And so this uses capitalized name, uses spaces, and uses capitalized word. And here let's keep copying and pasting capitalized shipping notes, F0. So the good thing about this is, oops, not name, shipping notes. The good thing about this is we are being explicit about our functions intentions in each function we create. We created three mostly identical functions by copying and pasting, but actually we're adding value because we're reducing the complexity of each individual function. And we're making code a lot more readable. And the good thing is we can actually split these in projects too. I mean, we can move the functions about file name in its own class, and we can move them to another project without needing to move anything else. It lets us to be more flexible. And similarly, file name, let's copy paste again. Let's repeat ourselves. But let's use this as a separator, and oops, and instead of word file name component we created with copy paste again. Yeah, so yeah, let's try this now. Okay, shipping notes, leave it at the door. I should have made this a macro. Invoice report.xls. Yes, it's working beautifully. And this is basically how we can achieve a better code by repeating ourselves in certain cases. We shouldn't rely on dry principles like dry solely, but we should use our own judgment in order to create copies of functions in case we anticipate a complexity appearing in that context. So basically, yeah. Let me show you a diagram about this from the book again. So here we have an isolated code here. If it's just a code by itself, if it's just some code by itself, it can be moved anywhere and changed freely without a problem. But when you create a dependency, in our case, let me go back to Visual Studio. What's the dependency there? And let me show you. So this part of the code depends on capitalize, right? These three blocks of code depends on capitalize function. Use the depend on capitalize function. And what we wanted to do was to just rescue ourselves from this kind of coupling, like this kind of binding between those, because it can tie our shoelaces together. These code can be dependent in a single source code as well. I mean, this code could be in another assembly, another project, another class. I wrote these in the same file for the sake of ease of tracking, but this could be the capitalized file name could be in another class, and that creates a dependency to that piece of code. And because of that, we actually get dependency-based, coupling, and that causes us to create extra stress on the code, because when you have multiple pieces of code depending on a single piece of code, and that needs to change for some reason, you might need to either update the clients in that case, or you might actually need to create a lot of complexity here in the shared code base. Instead, you should be creating multiple components in case where you're creating complexity in the code, when instead of being so stubborn on reusing the code. Yeah, so this is the part of the presentation about yes, we had a question about when to split methods. So let's go over this example we just saw right now. Basically, anything that is out of the scope of the function itself can be split. Okay, you got your answer, but let me reiterate at least. So we have this, capitalized file name component. Why do we have this in a separate function? Because how we capitalize each individual part of the file name isn't actually part of the whole capitalization process here. So it can be actually, and the more importantly, this explains what it does. If we moved this piece of code into capitalized file name here, like this. Now it becomes harder to track what the function does here. Not word. And it's getting harder to understand. So now you have to just understand what the function, what this code block does. You have to read the code in order to understand. But it's just called, capitalized file name component. You already know what it's doing. You don't really need to rest of the code to understand it. If you might, if there's a problem with individual component capitalization, but other than that, you don't need to. And I actually mentioned these topics in the book as well. Oops. Yeah. Okay. Oh, sorry. Let me go back. I'm having. Hold on. Okay. Sorry about that. I'll go over it again. So when we have capitalized file name component here, right? And I'm just copying and pasting its contents into capitalized file name function like this. And now what I have is less readable code. That's not. So this is readable, but you have to read each and every statement here. Like what's this doing? What's this doing? What are we doing here? But when you have just capitalized file name component there, you don't have to do that. So I hope that's clear. You could write, we are capitalizing each component here. You could write a code comment like this, but I'm actually against that. Instead of make your code more readable, instead of adding comments that could otherwise be explained by code itself. I'm not fully against code comments, but you can use them sparingly, only when it's needed. Otherwise, people stop reading comments. And I also mention that in the book too, in detail. Yeah, that's pretty much it. I'm gonna keep this on desktop just to make sure I don't make the same mistake again. And let's see how much time we have. We have just 15 minutes. Let me try to be really fast here. Okay. Or maybe we can. Okay, I'll try to be fast as possible. So copying. Copying is, in memory. The copy operation in memory, when I mention copying in this context. Copying is transferring a block of memory from one place to another, basically. And it's a slow operation because RAM memory is slower than CPU itself. Actually, orders of magnitude slower than the CPU. And because of that, we invented mechanisms that lets us to avoid the overhead of copying. And how we do that, basically, we are using, instead of copying every time a big data block from some place to another, we just use references to them. And references or pointers in archaic lingo are just small numbers that point to a certain location in memory, that points to that structure in the memory. And references are used as a managed version of pointers. Basically, references are like tracked pointers. The garbage collector can track references. That's why we have two different terms, pointers and references, but both essentially mean that a number that just points at a location in memory. And why are we using them? Because we don't want to first, we don't want to have the overhead of copying. And second, we want to be able to use the same structure we changed, and we want our changes to be visible in every place that references to the same location. That's basically how it works. And we still have some non-reference types like enums and structs. I'm not going to go over enums. I wanted to, but I can give an example about structs and why they exist, basically. Struct is just like a class, but it has value semantics instead of reference semantics. And value semantics, there are the value semantics mean that the structure by itself as a whole gets copied when you pass it to a function, when you assign it to a variable. So let's say you have a 10 kilobytes of data structure. When you have that, when you pass it around, you are passing, if you are passing it by value, you're passing it like a 10 kilobyte data packet everywhere. And that's slow. A reference on a 64-bit system, a reference is just 8 bytes. So when you pass around references, it's really fast. But when you copy 10 kilobytes of data everywhere, it gets slower and it accumulates. So that's why references are usually preferable. But that's not always the case. So I'd like to show you the layout of the class versus struct here. And as you can see, we have stack that we use as a memory, temporary memory for current function executing. And normally all your local variables are allocated on the stack. And when we allocate a class, we allocate two different memories. We allocate its reference on the stack, but actual data is allocated in the heap memory, which is a larger memory tracked by garbage collector. And as I said, I explained this in detail in the book as well, but here I'll just, give you the accelerated course on this. So when you class with a single 32-bit integer, like let's say ID class, let's say we have a customer ID class, and we also have extra data for that class, so it can be tracked and it can be used in object-oriented programming scenarios like inheritance and stuff. So we have extra data along with it. So in order to allocate just 4 bytes, you actually allocate 8 bytes here, 16 bytes here. So 28 bytes in total, right? But when you have a struct with just an integer in it, it just gets 4 bytes on the stack. It doesn't have heap allocation or anything. And why would I have a small class or small struct like customer ID, right? The good thing about this is, let me show an example again. Let me create a class here just for the sake of example. Let me see. Yeah. Let's create an example called customer ID here. So why would I have a class just for an ID? Something like this. Let's call this private set right now, or just it can say. So why would I have something like this? Customer ID, your business might require your customer IDs to be in a custom range. There could be invalid identifiers. For example, a valid identifier could be between 1 million and 10 million, something like this. And if you use an integer instead of customer ID, then you can basically get invalid value, and you have to validate that everywhere. And as I mentioned in the book, you can use this approach to actually avoid any invalid data throughout your program by using a custom class. And how can we make sure that it's a valid class? So basically, you first disallow it from being modified and just add a constructor. That's how I do it. So how I add a constructor, I just type ctor and click tab twice. I'm doing it slow so you can see it, and it receives an ID, and I just initialize the property with it, and I can add any validation logic here, right? So if ID is less than 1 million or ID is greater than then I can just throw an exception, out of range exception, like this. This is the right way of doing it. And so the good thing about this is, let's have another class. Oops. Is that you can actually have a function here that receives a customer, do something with the customer, right? Customer ID. What this ensures is, first, this functions only gets valid customer IDs, right? The second one is, it also ensures that it only gets customer IDs. Let's say you also have user ID, and it has the same semantics basically, but it's also between 1 and 10 million. Let's assume that. And now this kind of type distinction lets you to write correct code. If you try to call this, let's call it from another function, do something else, right? And let's create a user ID here. Oh, this is not the right format. Let's make it 10 million one. Yes, you can write numbers like this, so you can see number of zeros clearly. And let's try to do something with the customer. So it's basically not possible, and that saves you from validation. Basically, you don't have to validate your code each and everywhere. And the problem with this, though, we are creating a lot of overhead just to encapsulate a simple integer. And what we can do is we can just convert this into a struct and lose the overhead. Now they occupy the same space as an integer. Now if I create a new user ID here, it occupies only 4 bytes because it's an integer. It doesn't have all these overhead with garbage collector heaps, blah blah. So it's way better this way. And I think we're out of time. No, we still have 5 minutes, but I'd like to get some questions if you have some. Let me see. So this is the benefit you can get by copying the data, because the copy semantics of structs actually help you get better performance in these cases. Not every case though. Let me show you. If you have a large struct, then that gets copied every time, so it becomes inefficient. You have to use your understanding of this mechanic in order to make conscious decisions about this. In this case, it's preferable. And structs have disadvantages too. It has you cannot use inheritance or other object-oriented features with it. But the thing is, if you don't need that, you can definitely, in this case, in a case where the storage is smaller than what a class would cause with the extra overhead, basically. So, okay, let me see. For copying, here's a question. For copying, I saw a DOFS device example before, which is one of the first examples of array unlooping. I think today compilers take care of that, but it was a light bulbing moment. Yes, DOFS device, I think it may not be the first loop unrolling example, but it's genius in the sense that it used switch case statements in C. It actually abused them They Duff, I think his name was Tim Duff or Tom Duff. So he used it in a way that nobody would expect it to be used. So but I'm not sure if it's the first instance of unlooping, because the benefits of unlooping are clear. Like you can just you reduce the overhead of the loop instructions themselves by just adding more instructions in between. Um, yes, but yeah, unlooping is one of the ways that you can add to the performance of your code. So yeah, I think I don't have time to go into the rest. Maybe we can do other sessions in the future, so we can work on that. Let me know if you like the format that me writing code here live and running it just to, for the sake of example. And that's pretty much it right now. Let me know if you have any questions. See. Yes, thank you. All right. Okay, thank you very much. I'm glad to hear that you like the format. Uh, we'll do more if you like this. And as I said before, more of this stuff is in the book itself, Street Coder. Uh, Feel free to buy the book. It'll be released soon in upcoming months. It's still in the MEEP, Manning Early Access, but you can still read the book in ebook format until chapter 7 or 8 right now, and it'll be finished soon. So hopefully see you later, and thank you so much.